We have done this here this time. So first one is organic reaction, and obviously we are interested in reaction, and these are the how people write the one and identify the types of reaction, what will be the product on this, and you start from the identifying the what is called the functional group, and the functional group is something that is either pi bonding or something with a lone pair electrons. I'm going to use a green marker. So, okay, so this is a functional group, obviously. Yeah, this one is a lone pairs. I think the whole thing is a functional group, and this is a functional group. Okay? So I identify that, and the organic chemistry, this is just a alkyl chain that can be just controlling the boiling point or some kind of different shapes of molecule. But what's in the center of action is those thing with a functional group, and then it's now the times to understand what's the other one. So this is on hydrogen. When hydrogen and double bond meets, and we call the hydrogenation. And what it does is this double bond open up, and each one occupy being donated by the one. Essentially select the one of the hydrogen each, and so therefore I'll just do this way. So I'm just writing the short term the CH3. This is CC. So I'm going to write, and then this is a CH2, and they are going to form a new bonding of hydrogen and hydrogen here. Okay? So overall, you are going to have the chemicals that is going to be CH3, CH2, CH with a CH3 branch, and CH3. So those are the final product that you will have. The second one is your other reactant is a HCl, and this one dissociates into H plus and Cl minus. And an HCl is very, very small. Essentially, it's a proton or a hydronium. So they actually go to form H plus right there. Okay. So this one itself, the first types of reaction when these two, they are actually, this is an acid and this is a base. And so this is an acid, and Cl minus is their conjugate base. And this is a base, and this is a H2 plus is their conjugate acid, which is another problem that I'm going to solve today. So this is an acid-base reaction, okay? But that's not the answer they are looking for. They want an extra step you want to understand, which is this is an H3O plus, and they can steal 2 electrons to this. Leaving group is an H2O. Okay, so at the expenses of this chlorine, they're trying to find something trying to make a bonding here. And why this is happening, and this is talking in details. If you're looking at the connectivity, this carbon is connected to H3O plus, which is a plus charges. So this carbon is really pulling. This one is really pulling the electron to them in a form. So this carbon is really what they call the delta plus. They are partially positive. When you have a partially positive, easily being attacked by something called nucleophile, which is a Cl minus. So they're going to go and form the bonding, and they're going to say goodbye to this molecule. So what's the product on this? You're going to generate H2O, and the remaining one is CH3, CH2, CH2, CH2 with new bond being formed with a chlorine there. Okay? So I guess now I have a name. What has happened as a result is OH alcohol being substituted by halogen. So the name is halogen substitution. Substitution. So just say halogen sub. So the halogen substitution. Have you guys remembered this has been discussed in the class? Or yes? No? So I don't mind doing this, but this is, you gotta kind of identify this. Okay, so the third one is, this is a, we call acid. You guys know that, right? This is a carboxylic acid. And when acid meet with an alcohol, this is an alcohol, another functional group, and they form what we call ester. So alcohol meets and then at the expenses of losing H2O. So it's more like you look at here, there's a OH here, there's a hydrogen here. The other one is going to lose in a form of H2O. I just put a very simple way of explaining these things. So by doing so, you are looking at here on the left hand side, I have a 1, 2, 3, 4, 5 carbon. So 1, 2, 3, 4, 5 carbon with this ketone remaining, and then I guess third carbon has a methyl attached. So I didn't write anything, but you guys can complete the writing. But what's important is this is coming from acid, and I am going to write different color, let's say the red, and then there's an oxygen CH2 CH3 from alcohol. So by doing so, you are combining acid and alcohol. You are creating new bond, which is a COOH. That is an ester bond. To form an ester, you have to release an H2O. So that's what acid and alcohol meets, ester being formed, and then the water is being taken out. And this is sometimes we call condensation. And I think that Dr. Ma probably talked about polycondensation, polyester, polyamide. They are losing water. Water, we typically say condensate, so the condensation reaction. Okay, the last one is this. This is actually quite similar to the one in the top. Just this one just simply being H plus, Cl minus, H plus going here with a lone pair electron. So now this one became plus. Cl minus is just a neighboring charge. So the H plus goes there. So this is simply acid base ring. That's the one. More complete version is here, acid-base reaction, and what are the products and what are the reactant, and you can simply check it, and you guys can do the practice here. Okay? So this is an organic reaction, and you can things can be done identifying the reactant, the functional groups on each reactant, and you start to have a little bit of a, in a way, the memorization. For example, the acid and the alcohol form ester with the water, and then when you have an alcohol with HCl, they form the essential OH is being substituted by chlorine. This complicated mechanism is something that we discuss more detail in the second year in chemistry major. But at the moment, you can just say halogen substitution. Those are something that memorization that you needed.